music composition, live performance, and live coding, and web audio in these contexts. We have 50 minutes presentations and 5 minutes questions. I think the presenters are all aware of that. Please use the Slack channel if you want, but there will be someone running around with a mic as well for the questions. The first presentation is called Composing Spatial Music with Web Audio and the WebVR by Cem Çakmak. Is that Cem Çakmak. And Rob Hamilton from Rensselaer Polytechnic Institute.
Okay, I'll just start the presentation. I was actually going to present the piece first and everything went fine this morning, but of course, now things are not working. But I would much rather show it to you first. Anyway. Hello, my name is Cem Çakmak, and I'm a doctoral researcher at Rensselaer Polytechnic, and my research is supervised by Rob Hamilton. And today I'd like to talk about how web audio is incorporated in a recent spatial composition. Composing spatial music, what do we mean by that? It's basically treating space as a musical parameter to be expressed in, just as we do with pitch, rhythm, and timbre. Such performances are quite distinct and unique because every setup differs slightly, and they're quite hard to replicate, and few people actually go inside the room and actually experience the full thing. So the practice, although it has a big history behind it, it's still sort of a niche because of its experimental nature, and also how much funding it requires to build these kinds of setups and actually manage everything. So it depends on a lot of institutional funding or patronage. So recreating past works is also a challenge. We usually talk about them but not actually experience them, and there are projects that undertake some kind of reconstruction of previous works, but they're usually not feasible. And the overarching question for the research is basically how can web audio technologies level this playground for composing, producing, and sharing spatial music. So we believe web audio and WebVR technologies can make spatial works more accessible and more inclusive for composers and audiences. Just a little bit of history, spatial approaches to electronic music have been around since people could pick up a loudspeaker and move it around in the room, basically. And overall, there are we can identify two different traditions and two different approaches in sound diffusion in multi-channel compositions. Idealist and realist approaches, where idealist approach is basically trying to convey a composer's intentions as precisely as possible to the audience, and this precision usually requires the listener to be in an exact spot, a sweet spot, as it's called. And ambisonic systems, like you can see here, ambisonic setups usually go on this idealist tradition where they're trying to capture and recreate a spherical sound field as accurately as possible. The higher order ambisonics provide more clarity, more resolution, and but it's well, one of the problems is it can only be listened from one exact location. Your head needs to be placed in an exact location to get the real effect. And the other tradition is a realist approach, and the realist approach to composing multi-channel electronic music is basically accepting these differences in experience and, for the audience due to a variety of factors. This could be the way where you're sitting in the room, the architecture of the space, or external disruptions. And the realist approach is to incorporate all of these in the piece as it's unavoidable. One example I'd like to give is kind of a personal favorite, so I just wanted to talk about that for a second. The Persepolis by Xenakis is a multi-channel composition, and it's actually much more than just a music composition. It includes lights, lasers, children running around over hills with torches and so on, and placed in an archaeological site of the same name, located in Iran. And well, so they tell me, I've never seen it or I've never really experienced it. And we often mention these kinds of examples, but we don't really know, very few people actually have been there and actually experienced the thing that the composer really intended to present. So we kind of, as we talk more and more about these things, we sort of have the tendency to mythify them, and which draws the conversation away from a directly musical one to more of a critical discussion. So spatial compositions are quite ephemeral in that sense, where you set something up, set up a very complicated system, and you perform it, and then you take it down, and it's hard to reconstruct again. Another approach could be acousmonium. Acousmoniums are basically asymmetrical distribution of speakers compared to ambisonics, which is very precise. Acousmonium try to combine loudspeakers that vary in size and shape, quality of response, and try to function them together and showcase something that's not only auditory but also kind of presents a visual novelty as well. For the context of this project, my objectives were basically bringing together a number of contemporary technologies together to compose and present this spatial music piece, and placing all listeners in that idealized sweet spot, which is naturally possible in a virtual world, a virtual space. In a virtual space, we can place everyone in the sweet spot, so that kind of levels everything. And finally, I wanted to capture a spherical 360 video of a physical site that's difficult to visit, and further augment its immersive qualities and using VR and ambisonic production techniques. Omnitone, I wanted to talk about the tools I used. Omnitone is the primary tool for ambisonic decoding to binaural on the web. And as you can see from the figure here, we can decode up to third order ambisonic streams. And we basically point to a file and create an audio buffer source node, which we pass a WAV file through, 16-channel WAV file in this case. And that is sent to the high order ambisonic renderer, which uses web audio native over and gain node interfaces. And the HOA renderer sort of gets information from a rotation matrix, which could be a sensor data or some interaction, or in our case, it's the camera rotation data from A-frame. And what is A-frame? A-frame is a 3JS framework for high-level VR development. And it has an entity component structure, which is usually more of a case in game development and interaction design. But basically, you sort of construct your components and attach it to other pieces, other entities. And in our case, we just needed to wrap a 360 video and make sure we can move around it and ensure it's compatible across browsers and VR headsets and so on. So A-frame is useful in that sense. And for composing the ambisonic environment, I use SPAT. And SPAT is a library of real-time spatialization tools for Macs. It provides a 3D environment for composition, and the 5th version implements OSC messaging, which is very useful for communicating with other programs and so on. And for the physical space, I wanted to bring in and introduce into the virtual space. I used a tech lab called Crave Lab. Crave Lab is an immersive laboratory with a 360 screen in the shape of a rounded rectangle. You can see from above here. And it has a panoramic screen. Along the back of the screen, we see an array of speakers, and above on the ceiling, there are additional speakers. These are for wavefield synthesis and ambisonic support. And it's located in a tech park that not many people can visit, and we have architectural classes in there, some performances, network performances, and so on. But its main function is to reconstruct real-world places in that place, and sort of try out architectural designs on a real site, and try to see how that works. this is what the architecture students do mostly. And our goal was to export Cravelab out, and so instead of bringing a physical site in Cravelab, we wanted to take it out and put it in a virtual space where people can experience it. To do this, we used GoPro Omnitone camera rig and placed it in a sweet spot, which is equidistant from everywhere, right in the center, and recorded the footage of footage playing on the screen, and then using effects plugins called WebVR, we sort of extended that screen in a spherical shape instead of a panoramic one. So the composition process involves navigating through these different environments, and the ambisonic scene is composed in Max and encoded in ambisonic and put out. And I have different versions of compositions, but mainly it's around 20 sound sources placed around the listeners there, and it's in a dodecahedral shape, very regular one, and head rotation. So the sound sources are almost identical, and they differ by phase and pitch. So as you rotate your head, the intention is to cause the sound world to become more active, since the proximity of the sound sources change, and despite you get these slight wobbles and pitch changes and so on. So it kind of encourages you to explore and move around. And extending the Crave screen, the first idea was to place reflective surfaces and mirrors around the screen, as you can see here. And then we sort of took that to a virtual place where we used like virtual mirrors to reflect the footage on the screen, record the footage on the screen, and expand it above and below the screen as well. And this is sort of like a retrospective composition workflow that I took out, so you can see the audio-visual design processes are quite different, but at the end they kind of sing together between A-frame and Omnitone, and that sort of becomes a piece. There are some discussion points that I can throw out, but if you have any questions, I would also be into discussing those, because these are also in the paper. But I really want to show you the piece. I can't do this now.
Change the sound source.
So that's it. Yeah, something's wrong. But,
want to try a different adapter?
I don't know, this changed a lot. I don't know what's going on. So this is like an earlier version. So you can see the panoramic screen here, and I don't know how much you can see actually. There's a lot of but basically you can sort of move around, and you can see almost like a dome-shaped construction. So this is the actual footage recorded with the camera and extended to the virtual VR phase. This is the good one, but well, I'll just FTP that on my website, and you can just check it out there, I guess. Yeah, no idea. But yeah, if you have any questions or comments, we can sort of discuss some things you want to bring out.
Brilliant. Thank you very much. So, Yeah, let's take questions. Are there any? So I would be interested in asking about the spatial audio library that you use, and if there are many competing audio spatial libraries, and if there is a lot of collaboration between people trying maybe to come up with a standard.
Yes, in my case, which is documenting and sharing spatial or electronic music, I think there are a number of there are other ones that I just use Omnitone because it was the it was the easiest and simplest, just on the go kind of thing. But there are other examples. It's still in the works. I see different people putting out different kinds of high-order ambisonic rendering on the web, but I think the main thing is in streaming high-order ambisonics. Right now we can stream. I think YouTube VR players stream first-order ambisonics, and also OBS. OBS also streams first-order, but above that we don't have anything. Streaming ambisonics would also take a load off the loading times and performance issues and so on. So I think in a couple of years, I think we'll have more options.
And do you find that there's a standard emerging that people will settle on, or?
In terms of libraries?
Yeah.
I can't really say. Things might change, but web audio-based decoding seems to be working very well right now, and I think taking the web audio-based libraries would be the way to go.
Mm-hmm. We have a question here.
Yes.
That's much more important. I'm not sure I'm perfectly understanding the technologies involved, but I was wondering, so it sounds like you're doing this in two different spaces, one using Omnitone to render, another using Spat5 in these wave field and high density arrays. And I was wondering if you could talk about the differences in experiences that people have using the binaural setups versus those giant loudspeaker arrays.
So in terms of localization, binaural is actually not so perfect. There are ways you can improve binaural audio. You can individualize your HRTFs and so on, but actual speaker setups would give you a much better sense of localizing sounds. But like I said, setting those up is kind of, you need a group of people. It's a management issue. And compared to that, binaural is much more on the go, and you can do it without so much budget. And converting ambisonic to binaural to share spatial music seems it's not the perfect way, but it seems like a good enough way to start a musical conversation between composers, not just to like archive it, but send it one-to-one sharing or one-to-many sharing and so on. Binaural, I think, would be a very good way to level that kind of playing field.
Okay, I think we have time for one more question. And could the next presenter come? Is that Jason Smith? Yes, please. Come and set up, please. And
Yes.
We take the next question.
So you mentioned Max, and this is obviously a browser with a JavaScript code that is doing something. So which part of this is Max?
I'm sorry?
Like the Max MSP that you mentioned that
Yes.
you're using.
So I put out the ambisonic, I encode into ambisonic format in Max. So Omnitone needs to read a file. You can't really stream through it. So I design and encode the ambisonic environment in Max, and I put out a 16-channel WAV file, and then point that to Omnitone and get things working that way.
So in this case, you kind of can use just Ableton or whatever other DAW in order to produce this kind of file. You just chose to use Max for that. Or is something particular?
You can compose. I mean, composing multi-channel Ableton. I guess you can use Max for live tools and so on. I just use Max, and it's much better to like. It's a much better environment to just implement ideas, see what's going on, because I also render it to binaural through Spat, so I sort of hear it as it's supposed to be heard on the web browser, but I do it through Max, and I decide everything, and you can get into more detail using the Spat library in my experience.